Hi guys, this is starting of chapter 2, lesson 1. It's relations and functions. And if you remember, we started talking about this in the review unit. So this shouldn't be all brand new, but some of the information will be new. Um, so to start out with, you need to remember what a relation is and what a function is. A relation is just when we take an input and an output, the x value and the y value, or you could also call it the domain and the range. When we take those two values and we pair them together, that's a relation. So there's nothing really specific about it. It's just I have an x and I have a y value paired together. In order for you to call a relation a function, you can only have the domain value, or the x, go to exactly one y value, or the range. You cannot have the domain paired with two different y values, or if you do, it's not a function. So make sure that each input is only paired with one output if you're calling it a function. So here's some other words that you're going to run into, and you're going to have to classify functions as either being one-to-one, onto, or both one-to-one and onto. For a one-to-one function, this one right here, each of the domain values are being used, and they each are paired with one range value because they satisfy the fact that it is a function. So each domain value is used, and it's going to exactly one range value. Now I don't care that this C is not being used because that's not an issue for this particular type. If we go over to onto, an onto function says that each of the range values has to be used. So although it still satisfies a function because each domain is only paired to one range, notice 3 is going to C, 4 goes to C. If I had 3 going to C and B, that would not be a function. But each domain value is paired with exactly one range, and the range values are all being used. Since they're all being used, it's an onto function. And if it's both one-to-one and onto, that means all of my domain values are being used. They're being paired with exactly one range value, and all of the range values are being used. So that's both. All right, so let's go down to this example here, and we're going to state the domain and the range of each relation. We're going to determine if it's a function, and then if it is a function, we're going to determine if it's one-to-one, onto, both, or neither. All right, so let's start with domain. When you write domain, I always want you to write D to identify that you're telling me it's domain, equals, draw a set brace, and since these are individual points, we're just going to list out the numbers for the x values. So as I follow my x-axis, I'm going to start on the left side to get my lower values, and I'm going to work all the way to the right side. So negative 1, 2, 3. There is a point that corresponds with negative 3. So negative 3 is a value. Negative 1, negative 2. There are 2 points here that have a negative 2 as its x, but I only have to write it down once. Negative 2, negative 1. There is a point at 0 for x. At 1. There is nothing at 2. If you follow up and down the x value for 2, there is one at 3. And there is one at 4. Close the brace. So that's the domain. Now let's write the range. Range, remember, is the y values. So again, I'm going to start from the lowest y values. The y-axis runs up and down vertically, So I'm going to go all the way to the lowest point. Down here, there's nothing here. -1, -2, -3, -4. There's nothing at -4. Look across. -3. There is a point right here that I would get a y value at -3. -2. There are 2 points, but I only have to write it down once. -1, there's nothing. 0, there's nothing. 1, I have 2 points, but again, I only have to write it down once. At 2, there are 2 points. I only have to write it down once. At 3, there is nothing. And at 4, there's 1 point, so I'm just going to write down the 4. So now you have listed your domain and range. We need to determine if it's a function. What you do to determine if it's a function, if you have a graph, is you look at your x values. And as you go across looking at those x values, if you have an x value that gives 2 different y values, then it's not a function. So when I look at this x value of -3, I only have one output, and that would give me an output up at 2. So at -3, 2, that's the only point that's placed. If I go to -2, -2 could either be here or here. So with an input of -2, the x value of -2, I get 2 different y values. They're at 2 different heights. Okay, so this is not a function because I cannot have 2 outputs with that one single input. So not a function. Okay, and then we need to determine if it's one-to-one, onto, both, or neither. Well, it's not a function, and all of these are definitions of types of functions. So since it's not a function, it's neither. Let's look at this example. First, let's identify the domain and range. Even though they've written it out for us that way, let's write it like this. -3, -2, -1, 0, and 1. All I'm doing is copying it. I'm just writing it in this notation. 0, 2, 4, 6, and 8. Okay, let's take a look at how they're paired together. First of all, we need to determine if it is a function. So -3 gives me 0. Is it paired with anything else? There is no other arrow, so no. -2 is paired with 2, and I don't see it paired with anything else. -1 is paired with 6, but I don't see -1 paired with anything else. 0 is paired with 4, and it is not paired with anything else. 1 is paired with 6, and it's not paired with anything else. So, because all of my x values or my domain values have exactly one range value, it is a function. And if you go back to this side, something that I didn't specifically say when I was talking about one-to-one is that every time a domain goes to a range value, it has to have its own range value. So I couldn't have 2 going to B and 3 going to B because they would share that range, and that wouldn't be one-to-one. Each of the domain has to have its own unique range. So if we look here, the -3 goes to 0, that's fine, but we look at 6, and even though it is a function, -1 has 6 and 1 is paired with 6, they're sharing that 6, so it's not it's not one-to-one. As we look at the range, not all of the range values are being used, so it's not onto. So it's neither. Even though it's a function, it cannot be classified as one-to-one or onto. So this one is also neither. Discrete and continuous is something else that you need to know for this lesson. Um, if, if you have individual points like in graph A, where you're only talking about specific places on the graph, that is called discrete. If your graph is connected and it has no gaps in between, then that is called continuous. So some examples here would be for graph B, a continuous relation would be if you are given an equation of a line or any other kind of curve, any other function that doesn't have breaks, but a graph of a line and you put in information, you can use any x values you want to try to figure out where the graph goes. For a discrete relation, think about if you're getting data from different places. Let's say there is a festival that's held every year and they count how many people attend the festival. So the first year, they'll have a number that tells how many people went to the festival. The second year, they'll have another number. The third year, they'll have another number. And because the festival does not continue on throughout the year, we're not going to stay at the festival and people keep coming in. It's one specific moment in time each year, so it would be 1 point each time. So that's the difference between discrete and continuous, and we'll look at some examples of that too. By the way, if the function or the relation is discrete or continuous, you can use the vertical line test to determine if it's a function. Back here, when we determined it was not a function, it didn't pass the vertical line test. If you run your pencil or anything else vertically across the points, and any two line up vertically, so right there, these two line up vertically, if you ever come across that, then your graph is not a function. So I am going to make another video for the rest of 2-1 and watch it.